Nikola Tesla's Forgotten Inventions. Part 1: The Man, the Myth, and the Dream of Free Energy. Before we chase coils and towers, let's humanize the guy with the lightning. Because understanding how Tesla thought, his habits, his strengths, his blind spots, makes the later wins and stumbles make sense. The brain that drew in 3D Tesla had this almost cinematic visualization ability. He'd build machines entirely in his head, spin them, stress test them, tweak clearances, then finally commit to metal. In lectures he bragged, half humbly, half mischievously, that he could spot a flawed bearing by how it sounded in his imagination. That superpower let him iterate fast when materials were expensive. The flip side? He sometimes skipped drawings, which later engineers needed. When he moved on, the blueprint often lived only in Tesla, the AC triumph, and what it did to him. We make it a single headline: Tesla wins the war of currents. Reality? Years of patent fights, hard engineering on polyphase motors, and the sheer sweat of getting Niagara Falls to feed AC into cities safely. Westinghouse buys key patents, Tesla becomes briefly solvent, the Columbian Exposition lights up in white-hot AC glory, and the world pivots away from Edison's DC for long-distance power. That kind of win changes a person. For Tesla, it proved that theory plus nerve could rewrite infrastructure. After that, reaching for the next revolution felt not only possible, it felt necessary. The press, the persona, and the money. Tesla wasn't a carnival barker, but he understood theater. He'd fill a hall, dim the lights, then make glass tubes glow in midair with radio frequency fields. He'd let current pass through his body and exit as violet corona from his fingertips, harmless at those frequencies, spectacular to watch. Newspapers turned him into a folk hero. Investors, though, need line items: cost, efficiency, market, payback. That's where his charisma sometimes outran the spreadsheet. He could sell the vision, he struggled to tolerate compromise. So, free energy, what did he mean? Let's parse the phrase because your viewers will comment this to death. Free as in freedom, wireless power without wires. The fantasy is a world where factories don't string copper across continents. Instead, energy is coupled through the environment to receivers. That's free like free movement, not free like free beer. Free as in source, ambient devices harvesting energy that's already there: sun, wind, geothermal, tides, atmospheric electricity, maybe high-altitude currents. Still absolutely allowed by physics, but bounded by what nature provides and what your converter loses. Free as in perpetual motion, nope. Tesla publicly mocked perpetual motion, what he called trying to get more out than in. He worshipped efficiency and abundance, not loopholes in thermodynamics. Why the confusion? Because the headline free energy blurs those distinctions, and Tesla's own metaphors, harnessing the wheelwork of nature, sound like you're plugging into infinity. In his head, infinities meant the planet-scale reservoirs of charge and motion that physics obviously contains, not magic resonance, the melody he chased. If you want one word to carry through this series, it's resonance. Two violins tuned to the same note will sing together, bow one, the other hums. In circuits, an inductor, L, and a capacitor, C, tuned together will swap energy back and forth at a natural frequency. Add just the right push at the right time, in phase, and the oscillation grows without you having to force it every step. This is why Tesla kept stacking coils, spheres, and ground plates. He wanted a big, loss-leaning swing set that, once pumped, would share energy over distance. He extended the metaphor to the Earth. What if you could set up standing waves in the Earth ionosphere cavity and then tap them at distant points? Signals? Sure. Power? He believed perhaps yes, if you drove the right mode, managed losses, and made receivers that matched the wave. Modern take, we totally do resonance, wireless chargers, RFID, NFC, induction cooking, magnetic resonance imaging. We even use VLF to send submarine messages using the Earth as a conductor. But bulk power over oceans with low loss and easy metering? That remains, to be polite, stiff the entrepreneur problem successful founders pivot. Tesla pivoted philosophically, but not always commercially. After AC's victory, he spent more time on the next horizon than on the near-term products that could have financed it. Westinghouse had factories, Tesla wanted frontiers. Those are different muscles, habits, quirks, and the lonely climb. He slept little, walked obsessively, insisted on precise table settings at dinners, avoided certain textures, adored pigeons, and kept a ritualized life that looked odd even to friends. None of that invalidates the work. It reminds us genius is often narrowband, blindingly bright in one frequency, fragile in others. All this sets the emotional stage for Colorado and Wardenclyffe, a man convinced he's already changed the world once, ready to try again, this time with the planet itself as part of the circuit. Hold on to that picture as we roll into part 2, the barn that made thunder, and the tower that never quite sang. Part 2, Lightning in a Barn, Colorado Springs and Wardenclyffe. Let's climb into that wooden lab in Colorado Springs, because the details read like steampunk cinema. The lab that opened to the sky. Tesla builds a shed with a sliding roof so his giant coil can throw streamers into open air without incinerating rafters. The secondary coil is huge, wound with many turns of wire, coupled to a primary that's basically a heavy loop and a capacitor bank made from jars or plates. A spark gap acts like a switch, charge builds, the gap fires, and the LC pair rings at radio-like frequencies. The top of the secondary carries a big terminal, sphere or toroid, to smooth the electric field and prevent premature corona when it's tuned just right. Blue-violet snakes creep across the room, metal objects sing with corona, and fluorescent tubes glow in people's hands with no wires. He maps where bulbs shine brightest and finds the nodes of the field. Primitive field strength surveying, a measurements that mattered under the show, is a method. Tesla carefully tweaks coupling coefficient between primary and secondary, too tight energy dumps fast and rings messy, too loose weak transfer. Top load size, bigger sphere raises effective capacitance, lowers frequency, tames breakout, ground system, rods, plates, moisture, all of which change the return path's impedance, frequency, from tens of kHz to a few megahertz. Each regime behaves differently. He keeps notebooks on breakdown voltages, spark lengths, and how displacement current will happily take capacitive shortcuts that look mystical but are just Maxwell. The city blackout story, legend with a grain. You'll hear the tale. Tesla flips the switch and the local power station dies. Was that literally his coil backfeeding the grid? The boring engineers answer, his experiments likely loaded the station or caused protective trips. It's not sorcery, it's coupling plus the soft underbelly of early infrastructure. The fun answer? People in town blame Tesla's lightning. Both things can be true, a dramatic event and a mundane physical explanation. Lamps at a distance. He reports lighting incandescent lamps at distance using one terminal and earth return, or by placing bulbs in intense RF fields. You can reproduce the second in a classroom with a tabletop coil. Tubes glow from capacitive coupling. The first is trickier. Single-wire systems actually use the environment as the other conductor. The magic is that high-frequency currents don't need a closed copper loop the way DC does. Fields complete circuits scaling, where the dream hits math close in. You can move tens or hundreds of watts impressively. Over kilometers, field strength drops, and picking out one receiver from the air is hard, unless you go directional, antennas, beams, or resonant, tight coupling. Tesla hoped Earth mode coupling would beat inverse square radiation losses. Modern experience says, you can launch very low-frequency signals that hug the ground or reflect off the ionosphere for comms, but the power density at a distant point isn't your friend unless you focus with antennas, and at VLF, antennas are enormous. Wardenclyffe, The Big Bet. Fast forward to Long Island, 1901. The tower rises. Below it, a deep shaft. Above, a steel dome. Beside it, a powerhouse to feed the transmitter. Tesla's letters to J.P. Morgan promise the practical first, secure global telegraphy, cheaper and private compared to Marconi's spatter all directions radio. After the comms phase, Tesla hints the system could distribute power. Investors see a revenue line in messaging. The power talk sounds vague. Then Marconi broadcasts a headline-grabbing transatlantic signal in 1901 with a makeshift antenna. The press swoons. Why pay for a skyscraper-sized science project when a bamboo pole and wire work? The business knots. Morgan asks the brutal business questions. Where's the exclusive advantage? How do we meter power delivered through the air? Why won't everyone just eavesdrop on my energy? Tesla, ever the visionary, answers with eventualities, network effects, scale efficiencies, humanity's progress. Bankers here, risk.by 1906, the money spigot closes. The half-finished tower becomes a monument to potential. Tesla mortgages, remortgages, and ultimately loses the site. During World War I, with spy fever high, the government dismantles the tower. The foundation stays, a concrete fossil of a dream. Could a modern Wardenclyffe work? We can imagine hybrid futures, localized wireless rooms, labs, factories, where ceiling transmitters keep tools and robots topped up. Beamed microwave links from one island to another, metered and safe. Space-based solar beaming to rectennas with tight side lobes. Those are narrowcast cases with tight control. Tesla's broadcast ethos, power for anyone with a tuned receiver, is hard to monetize and hard to make efficient at scale, but give the man credit, he saw wireless everywhere before the world had even wired itself completely. He got the direction right even if the distance was optimistic. The ethics and the poetry. Tesla believed in abundance, that civilization advances when energy gets cheaper and cleaner. He wasn't cynical about profit, he just wanted progress first. If you squint, Wardenclyffe is an ethics project as much as an engineering one. How do you organize a system where access is wide and control isn't abused? That's the same fight we have with internet access, open standards, and clean energy today. So when we say the tower failed, let's be careful, the hardware didn't sing, but the song, resonance, coupling, openness, outlived the wood and steel. Onto the drawer of forgotten devices that prove Tesla was more than one idea. Part 3, Cabinet of Forgotten Tesla, Turbines, Robots, Oscillators and Light. Let's pull the drawers all the way out and really look. Bladeless turbine. Why engineers still smile at the equations. Imagine thin, smooth disks stacked with small gaps. Steam enters tangentially at the rim, spirals inward toward the hub, and exits. The working fluid doesn't slam blades, it clings to the disks via the boundary layer and drags them by viscosity. At small scales, where Reynolds numbers and surface finish dominate, this can be beautifully efficient. In 1911, making 10 flawless, warp-free disks was painful. In 2025, with CNC, EDM, and coatings, making miniature disk packs is routine. Where's it useful now? Microturbines for waste heat recovery, pumps for delicate fluids, compressed air gadgets, even education kits to teach viscous drag. Could a Tesla turbine beat modern bladed giants in a power plant? Probably not. Could it occupy a niche where quiet, low maintenance, simple geometry matters? Absolutely. Telautomaton, Proto-drone thinking. Tesla's boat used early radio reception, think coherers or tune detectors, to translate coded pulses into commands. He even demoed apparent intelligence, toggling lights in response to audience shouts. The crowd thought mind control. He smiled and said, "Logic." That mental move, separate human intention from the vehicle, is the seed of drones, ROVs, mine clearance bots, and bomb disposal robots. The military caught up decades later. Tesla pitched it when radio itself was a novelty, a mechanical oscillator. Why building sway? Take a small device that pushes at a structure's natural frequency. Even a modest force, timed right, can produce large amplitudes. Tesla's desk-sized reciprocator allegedly rattled his lab so badly police showed. Whether the newspaper version is embellished, the principle is first-year dynamics. Modern takeaway? Engineers add tuned mass dampers in skyscrapers for the same reason: control resonance. Tesla's little box wasn't a city killer, it was an experiment that dramatized how timing beats brute force. HF lighting, light without wires, put a gas-filled tube in a strong RF field and it glows. Today we call it capacitive inductive coupling, back then it looked supernatural. Tesla also built electrodeless lamps excited by his coils, reducing electrode erosion, a real limitation of old bulbs. Health note: stand too long in intense RF and X-ray regimes of the 1890s and you'll get burns. Tesla documented skin irritation. He was an experimenter, not invulnerable. Out of those risks came lessons that fed fluorescent lighting, neon, plasma displays, and dielectric heating, vacuum and X-rays, on the frontier early. He tinkered with Crookes tubes, cold cathodes, and high voltages to generate penetrating rays, reporting shadow images and burns. History mostly credits Röntgen, rightly, for the discovery lineage, but Tesla was among the curious who pushed fields plus vacuum equals new phenomena. That curiosity is the spirit that later yields klystrons, magnetrons, TWTs, and more. One-wire stunts and displacement current. To audiences, a single wire lighting a lamp looked like violating circuit rules. But at high frequency, charge sloshes through capacitance to ground and across space. The return path is the field. Modern power engineers worry about this every day: EMI, stray capacitance, common mode currents. Tesla just made the invisible visible, tuned circuits, Tesla's quiet legacy. If you've ever adjusted an old radio with a variable capacitor and heard a station snap into clarity, that's Tesla's world: selectivity, Q factor, impedance matching. Today, your phone's front end and your Wi-Fi router are forests of tuned networks that behave exactly like those lecture hall coils, just smaller, cleaner, and made of silicon and copper traces instead of linen-insulated wire. The death ray, ground it in reality. Tesla's Teleforce proposal read like a high-voltage particle beam concept: accelerate charged particles and project them. Reality check: in air, charge beams bloom and scatter. Practical systems need vacuum paths or short ranges, plus huge power. Modern directed energy programs use lasers and microwave beams because they handle air better. Was Tesla wrong? He was too early and too optimistic about what could be fielded. He wasn't lying, he was pitching odds and ends worth name-dropping in your video: ozone generators and sterilization claims, some legit, some over-marketed, speed indicators, remote ignitions, arc lamps improvements, seismic prospecting ideas using oscillations, patents on valvular conduits, one-way flow channels with no moving parts. Today's fluidics fans love this. The point of the cabinet isn't look at the weird toys. It's notice the pattern. Tesla repeatedly reframed problems, asked what if we tuned this, and accepted messiness while he searched for the clean abstraction underneath. That mindset is the bridge to part 4. Get that free energy talk out of the fog and turn it into actionable, modern engineering sense. Part 4, Free Energy, what Tesla actually meant, and why it still matters. Let's do the bit everyone came for, the myth surgery, and then end with a hopeful, practical map, wireless power, 3 regimes. Near field, inductive or resonant centimeters to a meter or 2. Coils couple magnetically, efficiency can be excellent when aligned. Phones, toothbrushes, implanted medical devices, warehouse robots. Tesla would nod, yes, resonance. Midfield, room scale meters to tens of meters. Efficiency drops unless you fill the room with repeaters, smart surfaces, or accept lower power. Use cases, sensors, trickle charging, displays. Great for no-contact environments, sterile labs, rotating machinery. Far field, beam tens to thousands of meters. Use microwaves, wave lasers and tight beams to keep power density safe and efficient. Practical for point-to-point links, remote sites, drones in test ranges. Needs end-to-end safety, regulatory compliance, and rock-solid beam control, global broadcast to everyone, all at once, metered? Still a unicorn, ambient energy, what's real right now, solar, panels everywhere, freeze at point of use, cost amortized over years, wind, aloft kite turbines and tethered drones taps stronger high-altitude winds, very Tesla in spirit, waves, tides, dense but harsh environments, engineering is gnarly, progress steadier geothermal, gorgeous capacity where geology cooperates. RF harvesting, enough for sensors. Not your fridge, nanowatts to milliwatts realistically unless you sit inside a broadcast beam on. Purpose, thermal gradients, Seebeck devices scavenge micro to milliwatts from hot pipes or skin-air differences, and nothing here violates thermodynamics. Everything here smells like Tesla's abundance first mindset, distribute generation, reduce transmission, tune systems, store wisely. Why over unity myths stick to Tesla like static, a charismatic underdog versus stodgy establishment, a story humans can't resist. Half-finished projects leave gaps storytellers love to fill. Spectacular demos looked like magic to lay audiences. Conspiracy explanations are more thrilling than a VCs want ROI and physics penalizes leakage. You don't have to insult believers, you just have to give them a better story, the real one, which is plenty exciting. What a Tesla Honest 2025 roadmap looks like if Tesla walked into your studio and you said, "Help me push your dream without breaking physics." Here's what he'd likely point at: room-scale wireless for labs, factories, ceiling coils plus tuned receivers so benches, robots, and tools cut cords. Metered by coupling handshakes. Warehouse swarms, AGVs, AMRs that sip power while parked under resonant tiles. High-altitude wind pilots, kite turbine sending energy to ground stations. Space-to-ground demos, small microwave Rectenna fields with incredibly strict safety envelopes. Microturbo machinery, modern bladeless microturbines harvesting waste heat in factories, open standards for inductive power the way Wi-Fi standardized data, interoperable, safe, auditable education, kits that visualize standing waves, Q, and impedance. Matching so the next generation thinks in resonance by default. That program feels Tesla, yet every item ships within today's physics, metering and fairness. The unglamorous heart of the problem: Wardenclyffe crashes on 2 reefs, losses and who pays. Modern solutions bake handshake protocols into receivers so a transmitter knows who's connected and for how long. Think power tokens instead of letting anyone sip. For ambient harvesting, fairness is policy. You can pull microwatts from air, you can't mooch megawatts from a neighbor's beam without consent. That's where standards bodies step in, something Tesla the showman didn't have, but Tesla the systems thinker would appreciate. The ethics loop, what the dream is really about. When Tesla said free, he often meant freeing people from limits of wires, monopolies, geography. Keep that frame, and the dream is not a physics fight, it's an infrastructure and governance fight. Build systems that are robust, open, humane. The perfect end screen for your video is not mystery solved, it's mission ongoing. How to close your episode with clarity. Script beats you can keep. Wireless is real, but range and efficiency are a negotiation with nature. Ambient energy is everywhere, but power density and conversion decide what's practical. Perpetual motion? No. But abundance through clever engineering? Yes. Tesla's greatest gift wasn't a single machine, it was a way of thinking. Tune it, couple it, scale it, share it. Then ask your big engagement question. If you had one blank check to resurrect a Tesla project with today's tools, which would you fund, and why? Wardenclyffe 2.0 for secure global messaging? A city block powered by room-scale resonant grids? A manufacturing line driven by bladeless microturbines on waste heat? Invite the comments, and you'll get a goldmine of ideas from engineers, makers, and dreamers.